Yes, members.
Yes, teacher.
We'll be back. Ready? Is Ready hearing me? Ready.
Yes, teacher.
Ready, name me of you're not dozing. Lake. When you start talking like that, Ready will not understand you. Which language is that one? Ready will not understand when you start talking like that, Lake. Lake, Eunice. Bazara. Members.
Yes, teacher.
Let me hope the first session was we have understood in the first session, right?
Yes.
Okay. Now let's go ahead and see what I prepared for you today. And that one is the rationalization of the denominator. Can we write down? Rationalization of who is that one? Who is that one? Our lesson for today, our heading for today is rationalization of the denominator. Rationalization of the denominator. We said a number such as 1, can you be writing down, please? A number such as 1 out of root of 2 can easily be evaluated, by first expressing it with a rational numbers. So when we talk of rational, we remember we said a side is irrational. Side is what? Irrational. So we want to change it from irrational. We want to change from irrational to rational. And that process is called what? Members, that process is called what? Rationalization. Yes. So the process of changing a rational number to rational number, that process we said is called rationalization. Okay? Yes. Now, remember here we are dealing with it. For you to rationalize, we are dealing with only denominator. So which means we want to remove the root sign. We want to remove the root sign and the denominator. We want to remove the root sign from the denominator. So you can say, in a nutshell, to rationalize, you say to rationalize is to remove, is a process of removing, is the process, is to, is to, so bit is to remove the side, or root signs, remove root signs from the what? From the denominator. So once you remove the square root sign from, the root sign from a denominator, that one we said you have what? Rationalized. That's why now we are saying the process of converting an irrational denominator to a rational one is known as rationalization. Let's take example. Let's look at example. If I have 1 out of root of 2. Now this one we have a single root sign. We have a single what? Root sign. If I want to remove this root sign from the denominator, what I will do, I will multiply all through. Are you together, members? I will what? Multiply all through. I will multiply the denominator and denominator by the square root sign. So I will multiply the denominator by root of 2. I will also multiply it by what? Root of 2. And in this case, you have not changed the meaning because this and this can go away, which means you have not changed. But only that you are converting it in another form of writing it. Only that you want to remove the square root sign from the denominator. But does not mean that you have changed the meaning. Are you together, members?
Question.
Yes, please. Yes, please. Now looking.
Where did the 2 come from?
Which 2? This one.
The other one. Yeah,
This-
those ones.
These ones, eh?
Mm.
Now, I want remember I told you if we want to remove the root signs from the denominator, then we must, for you to do that, you have to multiply both denominators and denominator by this one. We are multiplying it this by this one. Now looking, the square root is this one, okay? Because I want to remove the square root from down here.
Yes.
But to remove it, I have to multiply both denominators and denominator by the same square root here. Okay? Now looking, is it okay now?
No, I've still not understood.
Yes. Now, what I'm saying, members, I have 1 out of root of 2, right? That's the number I have. I want to remove this square root 2 from down here. I want to change it from irrational to rational. So for me to do that, I have to multiply both denominators and denominator by the same square root. By the same what? Square root. And me doing that, I would have not changed the meaning of this. So what I will do, I will multiply denominator also by root of 2. This very one also by root of 2. Have you seen that?
Mm.
Now looking, have you seen that?
Yes.
Uh-huh.
So teacher, what happened to the 12? The 12.
There's no 12. There's no 12.
Oh, so okay.
Yes, it's all we have root of 2 only. So now you'll have in a denominator now you'll have 1 times root of 2. You'll have 1 times root of what? 2 over root of 2 times root of what? Root of 2. Remember, you seeing that?
Yes.
Yes,
What is 1 times root of 2? You get root of
Root of 2.
over what is root of 2 times root of 2? What do you get? We get root of
2.
Root of 4.
root of 4, which is it? But root of 4 is what? Is it?
2.
Is it 2? Now you see that. Now this is it. This has been rational what? Rationalized. Why? Because there is no square root in a denominator. You see, we have removed the square root from the denominator. Are you seeing that?
Yes.
And that process is what we call what? That process is called what?
Rationalization.
As simple as that. Now, members, you can see I've not changed the meaning of these. You pick your calculator and see. Pick your calculator and see. Our number was 1 out of root of 2, not so?
Yes.
You press. I'm going to press that. I have 1 divided by root of 2. Have you seen that? 1 out of root of 2. What do we get? We get what?
0.7.
0.707, right? That is before rationalizing.
Yes.
Before what?
Rationalizing.
Now let's see the one that we have rationalized now. The one that we have rationalized is what? Root of
2
divide by.
Divide 2.
The answer must be the same. Are you seeing that? Is the answer not the same?
It is the same.
Is the same. So what we are doing, we are not changing the meaning. Only that we want to remove the denominator. We want to remove the square root or the root sign from the denominator. Are you together, members?
Yes.
Are we together on that?
Yes, teacher.
Yes.
Very good. Let's look at B. Let's look at B. In B, they have given us 12 out of root of 18. Members, have you seen that?
Yes. Yes.
But before even we rationalize, we first start by simplifying int. Int, first, simplify. First what? First simplify.
Simplify.
Root of what? 18. Because this one is still big. This one can still be simplified. We must, when we are rationalizing, we have to deal with simplified surds. We have to deal with simplified what? Surds.
Surds.
So you will find that root of 18, which is the same as 9 times what? Times 2. So this one will give us root of 9 times root of 2. The answer is what? 3 root of 2 members, not so?
Yes.
Let me hope no one is dozing from there. Very early in the morning, some of you are very good at dozing. Bazara, I'm scared. Are we safe?
Yes, teacher.
Okay. So we have a 12 out of root of 18. So we shall have 12 out of, we have simplified root of 18, which is the same as 3 root of
2.
Now I want to remove this square root from down here. What should I do? What do we do?
Multiply by root of 2.
I have 12 out of 3 root of 2. But even before we remove the square root, we said there's a common factor here. I think that there's a common factor 3 and 12. So by 3, 1. By 3, so we remain with 4 over root of what?
2.
Now after that, now we come and rationalize 4 over root of what? 4 over root of what? 4 over root of 2. So we shall have 4 over root of 2. Ready? What do we do from there? What should I multiply with? Ready? People are quiet. Okay, Romeo. Romeo, what should I do here? Romeo? Yes, Romeo. Yes?
Times 2.
We multiply by root of
2.
root of 2 times root of what? Over
2.
root of 2. This one will give us 4 root of 2 over root of 4. So we shall have 4 over root of 2 divided by what?
Divided by 2.
By 2? By 2?
2.
So what answer do we have? We shall have 2 root of
2. 2.
2 root of 2. I want also to prove that. Let's prove that. Before rationalizing, we had, the question was 12 divided by root of 18, not so. Members, that was before, right?
Yes.
What do we get? We get 2.82.
2.82.
Let's see the one that we have rationalized. Now we have 2 times root of 2. Is it different? Remember, is it different?
Yes.
Is it different?
No.
They are the same.
No.
They are the same, right?
8 to 8.
Yes.
Yes. Very good. Very good. Members, that is how we
No,
rationalize.
different.
That's how we rationalize surds. When we have only a single root. I get me, members. When we have only what? When we have a single root in the denominator. Let's also look at this one. Let's put it as part C. Wait, example number 5 is here. Example number 5. They're saying simplify root of 5 out of 3 root of, 2 is 2, sorry, 2 root of 3. So who is going to take us through this step? Who can take us through this step? Yes, members. Who is going to take us through this question? Who is going, someone to take us through this question, please? Yes? Who can take us through this question? Who can take us through this question?
Okay, let me try.
Yes, please. Who is that? Who is that?
It's Letitia.
Is Letitia, eh?
Yeah.
Yeah, okay, Letitia,
You say square root of 5 out of the square root of 2 and 3. Root of 5 out of 2 square root of 3 times
Time?
2 square root of 3
Huh?
times 2 square root of 3.
We want to only to remove this square root. Are you going to multiply also by these 2? We are only going to remove the square root from here, okay? So we are going to multiply all through by square root of. I think that. Yes, you leave this 2 because this 2 is not under the square root. Okay? Are you together?
Okay, teacher. Yeah.
So when you multiply that, what do we get? We shall have root of 5 times root of 3, not so? Over 2 root of 3 times root of root of 5 times root of 3. What does it give us? It gives us root of 15 over this one will give us 2 root of 9. But root of 15 over 2 times root of 9 is 3, which will give us root of 15 over what?
6.
Is that something else we can do from there? Is that something we can do from there?
No.
Okay. So we leave our answer like that. Yes, members, can we unmute? Can we unmute? Can we mute our microphone? Can we mute our microphone, please? You only unmute if you want to say something. Only mute if you want to say something. To minimize on the noise in the background. Yes, please. Yes?
Yeah, when you still say the square root of 5 divided by 2, square root of 3, and we also carry this 2 times the square root of 2 square root of 3 divided by square root of divided by 2 square root of 3, we get the same answer as this.
I didn't get you when. What did you say? When we carry the 2?
Say like this. Yes. We still get the same answer.
When you take these 2, right?
Yes.
Yes, you still get the same answer, but the reason why I keep so that some people they mistake it because remember our interest only to remove the square root. Our interest only to remove the square root. You get the point?
Yes.
Yes. Because when you take it, you can take both. There's no problem with that. There's no problem with that. But you have to be conscious of common factors. You must always keep on simplifying. Okay?
Yes.
Let's also look at alternatively method 2. We can say root of 5 over 2 root of 3. You take also that. Okay? You take it like that so that because that one still you have not changed the meaning. Okay? But now when you put it like that, this one will give us 2 root of what? 15 over this will give us 4
root 6.
2 root of
9.
4 root of 9, which will give us 2 root of 15 divided by 4 times what?
Times 3.
3. Which will give us 2 root of 15 over what? Over 12.
Over 6.
By 6, I mean by 2, 1. By 2,
1. 6.
So you find that we still get the same answer. Members, have you seen that?
Yes.
Yes. So that's how we naturalize. That one we are saying if we have only one term, okay? If you have only one what? Yes?
Chart, if we cancel from the first equal sign, 2 root 15 over 4 root 9, and we cancel from there.
From here?
Up the upper one.
This one?
Yes. Yes.
You still as long as you keep on simplifying. My interest here, just keep on simplifying, okay?
Yes.
Yes. It must be in simplified form, please. As long as there are common factors, simplify it. Okay? Members, are we together?
Yes.
Yes, teacher.
Now, what we have looked at, that one is when we have only a single term. Okay? When we have only a single what? A single term in a denominator. What if we have more than one term in a denominator? What do we do? If you have more than one term, write it here. Write this one now. Are you seeing this note here? Are you seeing this note here?
Yes.
Yes.
Yes. So he said, suppose we have more than one term in the denominator, Suppose we have more than one term in the denominator, comma, in the form a plus or minus b the square root of c, comma, where a, b, and c are integers, where a and b are integers, comma, we multiply both the numerator and denominator by a conjugate, by a what? Conjugate side of the denominator. Members, are you seeing that? Members, have you seen that?
Yes,
Teacher.
This is it. We get the conjugate if we have more than what? More than one term in the denominator. Because like when you see what we have been doing, here we have only one term, we have 2 root of 3. I seen that here it was only 1. But what if now we have two terms in the denominator? What do? The step is it, we get the what? We get the what? The conjugate. Said that is the conjugate side of, suppose I have a plus b root of c. What will be its conjugate? The conjugate side will be, its conjugate will be What will be the conjugate, member? The conjugate, we change the sign. We change the what? The sign. If here is a positive, its conjugate will be a negative. If here was a negative, its conjugate will be a positive. So the conjugate side of a plus b root of c is going to be a minus b root of c. We just change the sign, the sign of the middle terms. Are we together, members?
Yes, teacher.
We just send the what? Members, what do? We change the what? The sign. If here is a plus, we change it to minus. Also, the conjugate side of a minus b root of c is, what will be the conjugate of this? What will be the conjugate of this? It's going to be a plus b root of c. Are we together, members? Are we together?
Yes, teacher.
Yes.
Who can explain how do you get a conjugate side of a given side of a denominator? How do we get the conjugate side? Yes, Letitia? Letitia, how do you get the conjugate side? Yes, Alexandra? Yes, Alexandra, how do you get the conjugate side?
So the sign changes.
Okay, good. So not to get a conjugate side of a denominator just change the sign between the terms. Just change the sign between the what? The terms to get a conjugate side of to get a conjugate side of a denominator, just change the sign between the terms. Between the terms of the denominator. Of the what? Members, are we together?
Yes, teacher.
Very good. Let's look at example. Let's go to examples. Example number 1. Let's just say, rationalize the following surds. Rationalize the following surds. A, let me say A. Here I have 1 over root of 2 plus 2. Root of 5 plus 2. Let's start with that one. So members?
Yes, teacher.
Yes.
So when you look at our denominator is denominator.
Positive.
Our denominator is root of 5 plus what?
5 plus 2.
But now you see this one is more than one term, not so. What do? We get the conjugate, not so? So what is the conjugate?
Yes.
What's the conjugate side? The conjugate side will be root of
Root of 5
minus 2. But after getting the conjugate, what do? After getting the conjugate, what do? We said we what? We multiply both the denominator and by the what? By the what?
by the conjugate side.
By the conjugate side. So which means now we shall have 1 out of root of 5 plus 2 times our conjugate side, which is root of 5 minus what? 2 divided by root of 5 minus what? Minus 2. Are you together, members?
Yes.
So when we multiply, we shall have 1 times that. We shall have 1, which is multiplying that. 1 times that will give us that minus 2. Not so?
Yes.
Over, put them in bracket, root of 5 plus 2 times root of 5 minus what? Minus 2. Now there's something I want you to remember here. Recall, when we are dealing with brackets, do you remember when we are dealing with bracket, I said if I have root a plus b is again multiplying c plus d. Is the same as the terms in the first bracket will multiply all the terms in the second bracket, not so? It's going to be the same as a into c plus d plus b into c plus d. Do you remember that? Members, do you remember that?
Yes.
That's what we are going to apply in the denominator here. So we shall have root of 5 minus 2 over into root of 5 plus 2 into root of 5 minus 2. So when you open this, so we shall have root of 5 minus 2 over, in our denominator we have root of 5, so we shall have root of 5 into root of 5 minus what? Minus 2. Then you carry this one with the sign, which is plus 2. Carry it with the sign plus 2 into root of 5 minus what? Minus 2. Members, have you seen that? Oh, good. Good. So we shall have root of 5 minus 2 over. Now, the next step is to open these brackets. Root of 5 times root of 5, what do we get? We get root of
25.
Minus root of 5 times root of times 2, what do we get? We shall get 2 root of 5, not so?
Yes.
Not root of 10, some will say root of 10, because this one is not under the square root. Okay? So they will just give us, yes. Plus 2 times root of 5 will give us 2. Positive 2 times negative 2, what do we get? We get negative?
4.
Negative 4. What can you say about this? Are you seeing this? Remember, you're seeing this term. Are they not the same?
Cross out.
It will cross out. This will cross out
Yes.
that. Then we remain with root of 5 minus 2 over, what is the square root of 25?
5.
5. Then minus?
4.
Minus 4. So we shall have root of 5 minus 2 over what?
Over 1.
Any number divided by 1 is that number, not so?
Yes.
So our final answer will be root of 5 minus? Minus 2. As simple as? That. Any questions so far?
No.
Good. B. B. Let me see. These are single terms. These are single terms. I want you to see which one can we look at. I think question is here. Remember, I think this question here.
Yes.
Pick for me one from there and we discuss. Pick for me one.
39.
39, eh?
36.
Okay. So we have root of 33 minus what? Root of 23 over root of 33 plus root of
23.
Now I will not go through all other steps I was talking about, okay? We shall just keep mentioning them, okay? Are you together?
Yes.
What do we do here? Here we want to rationalize. So what do? We get the conjugate. Not so?
Yo.
So who is that one with you? What do? We get the conjugate. What's the conjugate? Members, what is the conjugate? The conjugate will be root of 33 minus
Root of 23.
Over 33 minus root of 20.
Yeah.
What next? The next step is multiplication also. This is multiplying that. So which means we shall have root of 33 into this one, okay? Into root of 33 minus root of 23, not so? Minus root of 23 into, which is this one, into root of 23 minus root of 23. Okay? Have you seen that?
Shall you repeat? Shall you repeat that part? Shall you first?
Members, this term is multiplying this one, right? Not so? Not so?
Yes.
Which means I will have this minus this in bracket. This is one bracket. This is multiplying this. This with this. Have you seen that? Have you seen that? So which means this one will multiply all of these, right? This one will also multiply all of these. Have you seen now?
A question.
Yes, please. Yes?
So on the first bracket up of the question, what's the conjugate of the first number? Square root of 33 minus the square root of
We get the conjugate of only of denominator, not of the numerator. We get the conjugate of the denominator, okay? Okay? Members,
yes.
Okay.
we get the conjugate of only of the what?
Denominator.
Denominator, because we are rationalizing the denominator, okay?
Yes.
Are you together?
Yes.
Now, when we come to the denominator, we shall have root of 33 into root of 33 minus root of, not so? Plus root of 23 into root of 33 minus root of 20. The next step is what? Removing the brackets. The next step is removing the brackets. The next step is removing the brackets. Members.
Yes.
Yes.
Our time is running out, but after we join back, because we started our lesson late, after we join back, okay?
Okay.
In case you see me off, you join back. So we have root of, let me write it again here, root of 33 minus root of 23 minus root of 23 into root of 33 minus root of 23, right?
Yes.
Root of 33 into root of 33 minus root of 23 plus root of 23 into root of 33 minus root of 20. So let's start. Root of 33 times root of 33, what do we get? The answer is what? 33, not so?
Yes.
The answer is 30 minus we have 33 minus 23. We get square root of 500, 750.